This is another session today. We've got lots and lots of sessions running today, and this one is again another really informative and interesting session. We'll run for about, I think it's about 40 minutes. It's water recycling and harvesting. And we have four presenters for us today, and people who are going to answer questions. And they are Mark Stacey from Research Innovations, Laura Ryan from the Impossible House, Ian Knight from the Caringbah House, hope I pronounced that correctly, and also Tony Towndrow, who was the water engineer on the Impossible House as well. So we should get a few interesting things from those people. What I'll do is I'll quickly go around now and ask everybody in turn just to introduce themselves. Can I start with you, Mark? Just tell us a little bit about you and your house.
Sure thing. So happy for me to spend 1 or 2 minutes on it.
Yep.
There. Great. Okay. All right. So my place was a renovation of a house that was built in about 1970. I live on the outskirts of Melbourne, about 30 kilometres out of Melbourne, on 6.5 acres on a really steep woodland block. Our house is perched up towards the top of the hill on quite a narrow little terrace. And at the house, we don't have any connection to the mains water or the sewer network or the gas network. So we've had to do a lot in terms of water capture and the like during the renovation. So there were broadly sort of 4 different phases of work since we bought the house in 2015. And I'm just going to run through each of those briefly and maybe talk about a water highlight for each of those. So the first phase for us, we bought in late 2015, and then early 2016 did a renovation of the laundry and the kitchen. And as part of that, we replaced the old electric resistive hot water service over to a stable heat pump heat water service, and that's probably the main highlight from a water perspective. That's worked really well over the time since then. We did a lot of draft proofing during that first phase as well. And then in phase 2, we started planning for the big renovation. So from about mid-2016 through till late 2019, we planned and then implemented the big renovation, and that involved essentially going upstairs and a whole lot of retrofit of the existing footprint. One of my water highlights from that was a little device we got, an Australian-made product called a red water diverter, which I'll talk more about later, but that enables you to stop any wasted cold water that's in your pipes when you turn on the hot water tap. So that was really good. The third phase from us was doing upgrades to our water capture and treatment systems. So being off the sewer and the mains grid, everything comes from tank water. So we put in a whole bunch of new tanks at the top of the hill and some pumps to automatically get water off our roof and up into those top tanks. And for our wastewater system, we replaced a failing septic system with a worm farm wastewater treatment system, which has also been working really well. And my highlight out of that was just completely transforming the house from having a bunch of tanks that I couldn't, that weren't operating very effectively and always getting a lot to breathe them, to something that is very low maintenance these days and gives me clean water without too much thought. And then the fourth phase has really gone on throughout the entire time, and that's what we've been doing out in the landscaping, doing gardens around the house and the like. We've planted about 1,000 new plants across the property in that time, and spent a fair bit of time on the garden immediately around the house. Probably the water highlight there has been putting in drip irrigation systems for the native garden around the house, and that's also been working really effectively. So that's my little spiel, Michael.
Excellent. Thanks, Mark. We'll move straight over to Laura. Laura, can you tell us about the Impossible House? It couldn't have been impossible. The almost impossible house, perhaps.
Yeah, it's not done yet, so.
Oh, well.
So I'm taking a 2-bedroom workers' cottage on 104 square metres and turning it into an off-grid house. And most of the specialists that I've spoken to over the last 4 years have told me that what I'm trying to do is impossible. So hence the name. And with me today, I have water recycling specialist, the tenacious Tony Towndrow. And you'll understand why I'm describing him as tenacious when I explain what it is that I've been asking him to do. So, but first I'll kind of explain the motivation for the project. So around 2015, well, that was the hottest year on record. And around then I thought, bugger this, if our government's not going to do anything, then I'm going to do something quite drastic. So I bought a really tiny house on a horrible block with really bad orientation, terrible access, heritage constraints, and super small space as well, and thought, okay, if I can build a sustainable house on an impossible block and document it and make those that documentation available to everyone and make it really easy, and figure out a way to make the cost comparable to a normal build as well, then maybe more people would want to do this as well. And I think the other thing that I wanted to do was really challenge the, I guess, preconceptions and stereotypes when it comes to sustainable houses. So I think there's this, I think there's a bit of an image problem. So, a lot of my friends, well, one of my friends actually said to me that they wouldn't consider living in a sustainable house because they like taking showers. So I want to show that you can live in a sustainable house and it still has, the mod cons, and that I don't have to change my behavior in any way. All the switches still work, the shower still runs, all of that kind of thing. It's just that it's sustainable. The really difficult parts are figuring out how to bring costs down. And that's where Tony comes into this. As you can imagine, trying to recycle 100% of all of the water that I use on such a tiny block is really difficult to do. So if you live out, in the sticks, or you've got a bit of land, doing everything that I'm trying to do is a lot easier. But when you've got council constraints, heritage constraints, you've got boundary constraints, it's the design envelope is so much smaller. And so, I think I'm basically asking Tony to build a rocket ship out of toilet rolls and sticky tape, the equivalent of that. But he comes up with a solution, and I think it's great, but then it costs too much. So then we go back to the drawing board again. And so we've still got some, a way to go, but I definitely feel like we've got traction now on the water solution.
Awesome. All right. Well, it is an impossible house then, just at the moment. That's a great project. Ian, what can you tell us about Caringbah House?
Oh, I hope you can hear me okay. We moved in my Caringbah House in 2008. That's me, my partner, and 3 children. It's basically it's sort of in scale. It's just sort of in between Laura and Mark, really. It's in the outer suburbs of Sydney, so it's quite a big block. That's 740 metres. And it was originally a 5-row cottage, basically, to which built in the 50s, and they added on another 2-bed 5-row cottage in the 70s.
Sorry, Ian.
Yeah.
We're just getting a problem with your connection there.
Yeah. How's that? So I'll just keep talking and hope, or so. Yesterday I found I had to stop my video to get a good
we just need to come back to you there, Ian.
All right. It might be feedback on your speakers and mic, because as soon as your mic went off, the echo went off as well.
How's that with no video? Is that better?
That is better.
Yeah, we found yesterday that my bandwidth is pretty thin, and I have to keep killing the video.
Right. Okay. Let's go with that then, just for the moment. Just continue on with that, and then we'll move on to Tony.
Okay. Yeah. So, I was just saying, is this a 50s 5-row house added with a 70s 5-row addition, and so we started basically renovating in 2008, and we're still going. I can't see any end to it yet. We've been ripping off the asbestos bit by bit, replacing windows with double glazed windows, and putting shading and fans. We put solar panels on, and we got batteries, and yeah, we put a lot of water tanks in the place over the years as well. So yeah, it's just a sort of ongoing thing really, and it's just I could probably offer some advice on sort of ways you gradually get into a project. I've always wanted to have the funds just to do everything at once, but we haven't had that. So it's another end of the spectrum, I guess.
Fair enough. All right. Thanks for that. Tony, what can you tell us about your perspective on Impossible House?
on my perspective, as you can get an idea on an awful lot of projects, ranging from single households right up to fairly large.
We might have to ask you to turn your video off as well, Tony. You're starting to break up as well.
Laura asked me to join the project. I said, I like a challenge. Tell me what a challenge it is. I live myself on an acreage. I've got 5 acres, plenty of room.
Tony, can we ask you to just, Tony, just sorry to interrupt you. Can we ask you to turn your video off just for a moment? Because you're starting to break up a bit as well. Try again now.
All right, okay.
Oh, your video's off. Just have a go now and see how we go.
Okay. Right. Okay, how's that?
Oh, that's much better. Yeah, that's much better, mate. Thanks.
Okay. All right, so we're on acreage. We're not on town water, not on sewer. And for us, that's not too difficult. So we've got a pretty large house, an area 4 times the size of Laura's lot. We use not particularly water friendly in the water we use. It's a very old house, 50 years old. But we have a dam, a 1.5 megalitre dam, and despite that, we can still run out of water. And we have twice in the last few years. And I might explain a quick reason why, because I think it goes to exactly where you're building these impossible houses. We only had 340 millimetres of rain a couple of years ago, and 230 of that was in 1 month, which literally meant that 2/3 of the rainfall in the year went straight into our water tank, which promptly overflowed and went straight off down the paddock. And then the drought started. In reality, by the time it was finished, we had no garden, the dam was empty, we were buying water in from the carters, so you can still run out, even a large property, unless you recycle pretty well everything, and that's the issue with the impossible house, that we have to recycle everything and make sure you have a garden that actually works. And that is a problem, and what you're looking at now on the screen is a major section of the solution. You have to have a garden, and the house has to have a garden anyway, because it's not really livable. A house is not a home if it doesn't have a garden, and the council more or less insists that you do have some what we call open space, and Laura's open space is going to be on the roof basically. So there's the challenges, and yep, some of it was dealt with this morning on the impossible house saga. So sorry.
No, that's all right. Keep going.
Yeah, so go ahead. Laura might. Yeah, so basically we need to expand a bit on how we actually do it. Laura came up with the questions of how you do it cost-wise, and the answer is that you just have to work away at it, and you've got to ask some questions. And a house like this, it's how much are you doing because the law says you must, that you'd have to do anyway, even if it was a bigger house. So it comes down to regulations in the end. I think basically a good thing to go at this stage, if people want to do that, is to ask questions.
Yep. Okay. Thanks for that, everybody. I might open it up with one question. It's obvious that there's quite a difference in these projects, from a very, very small house to quite a large property. And so that begs the question, one of the questions we often get asked is, how much water do I need? So how much water do you need per day? I've heard some different results, but if you were just looking at one for the house and then out in the garden, what would your expectation be for a reasonable amount of water to be using in the house first? And I might start with Laura.
So we modeled it as 135 in the solution, but for me, I can use around 71 litres a day.
71, around 71.
Yep.
Yep. So 71 litres. That's a pretty good pretty good usage per day. So that was, so in your experience, that would be 71 litres per person, yeah?
Yep.
Yeah.
Yeah.
Okay. And what about you, Mark? What sort of water usage are you trying to get to within the house
Yeah,
per
sure.
person? Sorry.
It's actually really hard for me to measure because we have rainfall that's constantly coming in and propping up, and so it's hard to get a feel of how the rainfall's balancing out with the usage. Overall, I estimate that we're using about 300 litres a day, which is for about 5 people, or for 5 people, and that's pretty consistent with before we moved to the place. In previous houses we've lived in, it's tended to average about that amount.
So about 70 litres as well.
Yeah, I've always found that in Victoria there's a target 155 and always ridiculously high in terms of what we're aiming for.
Yeah. I think California was 300. So it varies around the place. Ian, what about you? What's your expectation of water usage in your house?
Well, I'm just trying to look up the bill. It's 31 kilolitres the last quarterly bill, so that's 31 divided by 95 days is anyone work that out? I think it's about 32 litres. Is that right? That can't be right, surely.
30 divided by 9.
No, sorry, 326.
326 litres a day.
Yeah, and that's the family of, well, we're 4 at the moment, but.
So again, we're talking about less than 100 litres per day per person. And Tony, do you have any idea about your actual house usage?
Well, our actual house usage, the house I'm living on, is about 120 litres.
120 litres
for 2 of us.
For 2 of you. So there's, again, it's about 55 litres a day. So those are pretty small figures because I know a lot of people use a lot more. So what about in the garden? Sorry, keep going, Tony.
How you look. It depends on how you calculate water usage. In Laura's case, we're talking about recycling and treating water back to the house. And her figure, she said, works out at about 70 litres, but by the time you add recycling and everything else in, we're actually looking at more like 45 litres per person per day.
Because some of it's used twice or 3 times. Figure. Yeah, exactly right. So
that's part of the solution, and part of why it becomes expensive.
Right. Okay. And so that's an interesting thing because you've actually effectively almost halved your water use because you're dropping it from 75 or 70 litres down. Yeah. And so where does that come from?
Okay. What I did was I ran the solution through basics. I think you'd all know basics. It's the water standard for the modern development that all renovations have to sustain, and they have to sustain a figure in water usage down to 40% of the usage that applied at the time basics was established. And basics at that time was 250 litres per person per day. So not a very difficult target to beat. And their target was to get down to 150. But when I put in all our water saving features and what we were doing in the impossible house, I got 95%. Now, if you think about it, that leaves 5%. And 5% of 240 is the 20th. Here's 200. It's 20 litres.
Right. So it's a really big saving. So we had a question from Violet, and I'll just.
It is. It's a lot.
Yeah, we had a question from Violet, which is, what's the first thing you do on an existing home then? Because I mean, with the impossible house, obviously you're doing a major renovation. With the other houses, they're existing houses. So I might just go across to Ian and ask you the first thing you would do on an existing home. What was the most basic setup you think you could get away with in terms of saving water or being efficient with water?
Well, the most basic one would just be a water butt underneath some gutter somewhere, really. But so basically, look at all your downpipes. The main thing is to look where your downpipes are on the existing house, because it's much easier to put your tank right under, or your water butt right underneath the downpipes. And if you can link them all together, that's all for the better. But basically, start off by choosing the most the one with the most room and the one that fits best into your way of life, really, that you can put a water tank under one of the downpipes if possible.
Right, so Mark, so having a water tank is one of the things to actually get hold of the water. So Mark, you've got a few tanks and dams and things. What's how do you actually work out where you get the water, what you do with the water once you've got it?
Sure. Okay. So I guess we've split our system into one that's for garden use and one that's for potable use. So everything that comes off our roof goes down into a lower tank, and then that automatically has a float switch to pump up to a top header tank of 80,000 litres. And then that supplies the entire house. And then we've also got a dam at the bottom of our property, and probably once or twice a year we'll run a petrol pump to fill up a 24,000 litre header tank at the top of the hill. Which we have that circulates through to our garden. So for us, it's pretty clear. Anything in the house comes from the rainwater supply, but anything otherwise comes from the dam. But I think in a way we're a bit advantaged because we don't have any restrictions about where or where you can't use water that comes off your roof within the house. Whereas if you're in the city, I believe there's sometimes restrictions about whether you can use water that comes off your roof for your shower and the like. Whereas we don't have that.
Yeah, and so we had another related question from Russell, which has said he has a 22,000 concrete tank, 22,000 litre under the house, 6 collection points, no water treatment. Any suggestions for ensuring safe drinking water? And I might Mark or Ian perhaps.
I'm happy to start with that. So I think first thing for me would be to try and do as much as you can to stop debris getting into your gutters. And so for us, we have a pretty good gutter guard, which cuts a lot out at the start. Then once it's in the tank, after that, I'd be suggesting putting in a cartridge filter. So it sounds like his tank is underneath the house, so he must have some sort of pump that's bringing that water back into his house. And so just after the pump, putting that through a simple little cartridge filter. You replace that every 6 months or so. That's all we use for our treatment, and it works really well.
Right, okay. Did you have anything else on top of that, Ian?
Yeah, I mean, the leaf filter at gutter level is a great thing. And then you need really to have a first flush pipe. So what I did with mine is the down pipes, I just basically cut them off right at the bottom end and put the cap on the bottom, and they become a first flush pipe. So the first shower that hits the roof, all the bird poo and all the leaves and stuff that get through the filter and the gutter and all the chemicals, first of all goes down the first flush pipe, and it's got a rising ball in the first flush pipe which rises up to the top, and then you have a branch just below the leaf filter which sends it off into your tank once that pipe is filled up. So and then that pipe just drains off slowly. You can drain it off into your garden somewhere. So that's a good thing to do.
Right.
The other thing, inside your tank, you can try and ensure that when the tank overflows, by having a pipe running around all the bottom of the tank, and then to your overflow, and the pipe's got little holes drilled in it, you can actually ensure that when the tank overflows, it's actually taking the more stagnant water from the bottom of the tank as well, and leaving the fresher water on the top. So this pipe that's lying on the bottom of the tank is connected to your overflow, so the water pressure will push it out from the bottom rather than out of the top where all the best water is. So that's a good thing to do for you. And I've put a cartridge filter on after the tank, same as Mark. Yeah.
Right. Okay. And so we had a couple of questions about we talked about tanks and things. There were a few questions related to what does a water reclaim system look like. And so, from your perspective, Laura, how are you reclaiming your water?
So there's a few elements to it. So there's the potable water and then there's the recycled water. In terms of the recycled water, it goes through a reed bed and then goes through UV and then goes into a storage tank, and then that storage tank feeds back into the washing machine again. So the washing machine is really the only place that we can reuse the water, so it's not safe to be used in other areas, for drinking or in showers or in the kitchen, etc. And one of the other issues for us, and this, when I first started looking at these solutions and started kind of building my own models and that kind of thing. Tony brought my attention to the fact that in my models, I stupidly did not account for the fact that as you recycle your water over and over and over again, you've got salt building up. And so then, you know, if I used any of that water on my plants, there goes my plants. And then also, if that water keeps going through my washing machine, then I'm going to destroy my washing machine as well.
Right.
So there's a part to the process which requires me using some of the water and taking it out of the system so that there isn't that build-up of salinity. So, and that requires, and Tony will be able to explain this much better than me, but that requires a absorption trench kind of thing. And we spent, I don't know, about 6 hours on a Saturday or a Sunday out the back digging holes in the backyard to see if the soil could could take water, and then using all these fancy and exciting engineering tools to measure the rate of absorption of the water into the soil. And really lucky for me that I didn't have a lot of clay. So if I had clay, I wouldn't be able to implement this solution. So yeah, that bit was I guess.
Harry and Laura.
Yep.
Harry and Laura, sorry to butt in. Harry, can you give me a moment, and Laura a moment? I think I can clarify for you, Laura, some of the issues. Would that be okay?
Yeah, sure, Tony.
Yep.
Okay. The difference between Laura's 70 litres per person per day and my 45 and my 25 is the 45 litres per day that a washing machine would be used if you use it twice a day. Sorry, every 2 days from the recycling water. So our figures do in fact equal each other when you take them and take it on to basics. So that was one point. And the other point, just to clarify for all concerned, if you're using the balance of the water into your garden, 100% recycled off sewer, then you would water a garden. And when you water the garden, you also get rainwater. Rainwater takes the salts that you're putting into the garden from the system and disposes it into groundwater. And that's the luxury we don't have on a small block, or very, very difficult to do, which is one of our prime problems. And maybe that, Laura, might explain a bit more on what you were trying to say. So I'm sorry if I butted in, but Laura, over to you. Keep going.
Oh, that's why I brought you along, Tony. So butt in. It's fine.
We're rapidly racing towards the end of our session. We had a specific question back to Mark, because you mentioned, Mark, before about having the cold water diverter, and a few people had wanted to know what that is and how that works, just briefly. And then after that, I've got another question here about people who've got an anaerobic system planned for a new build, and they were asked, wanting to know what sort of water could be diverted and used first without having to go through the system. So I might just take, Mark, I might just get you to answer that first question about the hot water diverter or cold water diverter.
Yeah, great. So the appliance or the device I use is called a red water diverter. So that's just an Australian-made diversion system. It's literally about the size of two of my fists put together. It's just a metal system that essentially the cold water you turn on the tap and cold water comes through to the hot water supply as the pipes are clearing out. It detects when that cold water starts to get warm, and so then as soon as during that process, the cold water gets rediverted, and in my case, it just goes back into the tank underneath the house. Other people could put it directly into their garden or the like. And then as soon as it detects the hot water's coming through the pipes, it automatically gives me full pressure. And so I've got those in each of my vanity units in each bathroom, and that services both the shower and the vanity together in each unit. So
there's a delay when you turn the tap on. There's a delay before the water comes out.
That's right.
So you've got to train visitors. That's the only downside with it. Yeah.
Yeah, the way it works is it has a really small trickle to show you that it's doing something strange.
Right, okay. Yep.
In my case, the longest run from my hot water service to the upstairs bathroom is probably about 30 seconds. So I have seconds of a little trickle, it goes full ball.
Right. Okay. Now we had the anaerobic system was planned for a new build. That was Kath, and also Eileen also was looking at a worm farm waste system. I'm really interested to hear what system people use for the worm farm system. Who was I can't remember who that was using the worm farm system.
I use the worm farm one. I can't speak too much about the anaerobic because the worm farm system is an aerobic system.
Yep.
So it actually has a wind-powered fan that brings air and oxygen through the system. The brand I used was A&A Worm Farm Systems. I think in Victoria they were one of two that had a EPA registration. So for us, anything with an EPA registration was easy to get approved.
Yep.
I'm not sure what that looks like across the state though, which brands have that approval.
Right, and okay, that's great. And the anaerobic system, I think I might either Ian or Tony, if you've got some knowledge about the anaerobic systems.
No, I've had no experience of those, Michael. So.
Okay, that'd be Tony then. Have you got experience with anaerobic systems or?
Well, basically what you're talking about is a septic tank and an absorption
Pretty much.
trench, and they're extremely common in all rural areas, but they're not really relevant to the sort of houses we're talking with almost total recycling, because they're just not environmentally friendly for anything. You're basically taking very basically treated water, putting it to ground. We should be looking at reusing our water. If we've got a garden, we should use it properly, not just disposing to ground is the last card in the pack.
Yeah. So would you
Laura's
restrict the water?
Well, we are disposing to ground. We're not disposing nutrients. We're only getting rid of surplus salt, which is no great environmental damage.
Mm. What about so
Sorry,
if you've got an anaerobic system like a septic tank, would you what sort of water would you be able to divert away from that septic tank to basically reuse or use first somewhere else, say in the garden? So I suppose we're talking about the difference between grey water and black water, which people may not be aware of.
None. When we moved into our house here, it didn't have a wastewater treatment, right? It just had a septic tank and a trench, and the water just went, and that was it, gone. Well, nowadays we treat it, and we don't recycle to the house, but the water's good. You can use it. Not in the house, because you're not allowed to use recycled black water in the house. Which is why in Laura's case, we're retreating grey water, because you are allowed to use that in the house. And you could use it for toilet flushing as well, except that Laura doesn't have any flush toilets. And the reason for that is if she did, then we then have to treat the black water to put it in the garden, and that would require more area, more treatment, more complications that we just don't have room for, nor the money either. So that's why. So you really, anaerobic systems are for the birds, literally.
Fair enough. I might open this last question. One question we have to finish up for Laura. So what sort of toilet system are you running, and is it actually in use, and what's it been like? What's your experience?
So we're building in early 2021, but the toilet that I'll be using is an incinerating toilet. So initially, I wanted a composting toilet because I wanted to cut down the water usage, but that requires an absorption trench as well. And again, 104 square meters means that's not going to work. Yep. So I have an incinerating toilet, and it does exactly what you think. So it takes the waste, sets it on fire, and then every week you've got about a cup of ash that you have to put in the bin. And the trade-off for me is because I'm completely off the grid, I had to weigh up all of the, reduced water versus the increase in consumption of electricity. So, every time I change one of these things, I have to go back to each of the project members and say, hey, I've changed this thing now. Can you please change your design for the solar to account for this? And then go back to the architect and say, hey, we need some more solar panels. Can you make the roof a bit bigger? And so that's kind of how it works.
Okay, and so have you had experience of any of those systems? Have you actually had some first-hand experience of those incinerating systems? And what was with
the composting toilet and the incinerating toilet as well. And Yeah, both of them work really well. I think the incinerating toilet is much easier to look after. With the composting toilet, you have to make sure that you rotate the base and keep on top of the compost and all of that kind of thing. And for me, because I wanted to make this house kind of as hands off as possible, so people don't want to move into a house and then go, oh gee, so now I have to deal with the composting toilet. So, yep. So I thought everything should just be kind of the same as if you were living in like a normal house. So I think the incinerating toilet kind of wins there.
Excellent. We're going to have to wrap it up there. This has been fabulous. We could have talked for another hour. I'm sure we could have had a whole day session on this and had everybody in here. It's been really interesting. I'd like to thank all of our householders. That was Mark Stacey, Laura Ryan, Ian Knight, and Tony Towndrow. And for their time and this afternoon. And remember, you can also see the stuff on Sustainable House Day, all the notes and their videos as well, and you can ask them questions on their own screens. We're going to be passing back over to Tom, I think it might be, to lead us into the next session. So thank you very much for your time, everybody. Thank you again to our presenters, and thank you everybody in the audience. I hope you found that instructive, and remember, there's a few more sessions going on.
Cool. Thank you, Michael.
No worries.
Thank you to all the panelists as well. That was a fascinating discussion, and I'm sure it could have continued for quite some time, but the show must go on. Our next session is, we are revisiting the topic of creating an edible oasis. This one will be emceed by Lou DiMattia from Cool Mob. And will feature representatives from Lakeside Community Garden, Zarcoli Organic Footprint Garden Farm, and Permanora. We are just going to watch a short video, and we really are going to watch a video this time, and we will be back to commence the session in a couple of minutes.